Hello everyone. In this particular video, we are going to solve the problem number 1.12 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So there are 3 points which are located at the vertices of an equilateral triangle whose sides equal to A, and they all started moving simultaneously with velocity v, which is constant in the modulus, and with the first point heading continually for the second, and the second for the third, and the third for the first, and it is asking to find the time after which they will converge. Okay, so let us first draw the equilateral triangle. Okay, so this is the equilateral triangle. This is the equilateral triangle, and this particular point, let us say A. This is the point, let us say B, and this is the point, let us say C. And point A is actually moving in this particular direction towards point B. Okay, and point B is moving in this particular direction towards point C, and point C is moving in this particular direction towards point A. Okay, and then this is the condition at t is equal to 0. Let us say after point t is equal to t1, the point A has moved by certain distance. Let us say it has reached to this particular point, and this particular length is very small. This particular length is very small. The point B will also move in this particular direction by some distance, and point C will also move in this particular direction by some distance, and all these three distance will be same because the velocity is same for all the points. Okay, now if we connect these 3 points, let us connect these 3 points. Then so let us connect this particular point to this one, then this particular point to this one, and then this particular point to this one. And then in this condition, the A will have the velocity towards B, that is what it is saying, and this is the direction because point B has reached this particular point, and then B will have the velocity in this particular direction, and C will have the velocity in this particular direction. This is the case at t is equal to t1, and t1 is very small time duration between 0 to t1. Let us say at what is happening at time t is equal to t2. Again, the point A will move by some small distance in this direction. Point B will move by some distance in this direction, and point C will move by some distance in this direction. Now again, if we connect these 3 points, let us connect these 3 points. Then the particle A is actually moving in this particular direction towards point B, and the point B is moving towards point C because point C has reached here, and then point C is moving towards point A. And if we observe carefully, then we can realize that these three are the equilateral triangles. Why I am saying the equilateral triangles? Because of the symmetry, and the velocity is constant. Okay, and then the length of the sides of the equilateral triangle is keep on decreasing, and it will decrease to come to a single point that it will converge to this particular point. Okay, this will converge to this particular point where the side length of the triangle is actually 0. So it is starting from the side length of A, and it is reaching to 0. Okay, now if we consider any arbitrary triangle, let us say this particular triangle, okay, this particular triangle, and the length of this particular triangle, let us say L. Okay, so this particular length will be L, this particular length will be L, and this particular length will be L, because this is the equilateral triangle. Okay, now if we consider that at what rate this particular length is changing, because we know that the length is changing from the side length of A to side length of 0. So basically it is reducing, the length is reducing. So if we want to know at what rate the length is reducing, then we have to find out what is the velocity of A in this particular direction and what is the velocity of B in this particular direction. Or if we want to know what is the rate of change of length of this particular side, then we have to know what is the velocity of A in this particular direction and what is the velocity of B in this particular direction. Okay, sorry, C in this particular direction. Or if we want to find the change in length of this particular side, then we have to know what is the change in length, what is the velocity of B in this particular direction and what is the velocity of C in this particular direction. Now if we consider the velocity in this particular direction, because we want to find the rate of change of length of this particular length, so if we see the velocity in this particular direction, then this is the velocity of A, and in this direction what is the component of velocity? This is V, B is equal to V, and this particular angle is 60 degree. So this particular direction velocity will be V cos 60 degree. And if we carefully look at here, then the velocity in each triangle in this particular direction is always same, that is V cos 60 degree. Okay, so that is also constant. Now we can write the minus of dl upon dt. Why minus? Because the length is changing and it is decreasing. We can equate it as what is the relative velocity of A with respect to B in this particular direction. So that we can write velocity of A, that is V, plus V cos 60 degree, and that is equal to V plus V by, sorry, this will be V by 2, that means 3V by 2. And if we consider this dt this side, then we can write minus dl is equal to 3V by 2 into dt. If we integrate both the side, then we can get minus L, the integration of dl is L, and then it is decreasing from point A to 0, and time is changing from 0 to t. So it will be A to 0 is equal to 3V by 2 into t from 0 to t. So this will be 0 minus of minus A is equal to 3V upon 2t, 2 into t, then t we can write 2A upon 3V. Okay, so this is the time at which all the 3 points will converge to this particular point. Thank you.